Hi guys, back again just for a very quick lesson. It's only going to take a couple of minutes, so just bear with me and then you can do the problems afterwards. Right, imagine you've got an object that's starting at some start point over here and it's moving to the right. So let's imagine we've got a wee car sitting here and this car is moving to the right in this direction. Now, at any point along here, it's going to have a displacement. And the displacement is going to be the distance from the start, in this case, because we're only going in one direction. So S here could be, say, 4 meters. So it could be 4 meters when it gets to this point here. It could be 4 meters away from the start. It could be 10 meters. It could be any sort of number like that. But it can also be a function. It can also be a function of time. So it could be, for instance, that it's actually 4 meters for every unit of time. So 4 meters for every second. If it's moving at 4 meters per second, then that would certainly be the function we've got. So we can have S as a function of time. So 4t here. So in this case, the speed, because this is effectively distance or displacement equals velocity times time, this bit here would actually be the speed. Now we can actually have something though that's a little bit more complex than that. We could have the displacement being a function of time like this. So let's say we said 4.2 t squared plus 3t. And we can maybe just put a number in afterwards just for completeness. So our displacement might be a function of time. Now in this case, it's not going at a constant speed. I happen to know that because I'm a physics teacher, but if it was a constant speed, then this bit here would be the only term in the equation. Perhaps you could have this at the end, but you wouldn't have anything with t squared. The t squared indicates that we must have an acceleration too, and I'm going to show you how. So let's start off with something a little bit simpler at the beginning. Let's just start off with imagining that we've got S equals 4t again. So similar to what we had back here. So if S equals 4t, then how would we go from this to finding out the speed? Well, you've got to remember that the speed is basically ds by dt. If you remember that from the previous lessons, then we're using this information again here. So because v equals ds by dt, then all we have to do, if this is our s function, is we have to differentiate it. So if s equals 4t, then ds by dt is going to equal 4. And that basically means that our speed here, which is the same as ds by dt, is 4 meters per second. The last thing we need to do here is to look at the slightly more complex formula. Let's have a look at this one here. Now we can differentiate this too. In the same way, if v equals ds by dt, then for this formula up here, if we differentiate it, then ds by dt is going to be 2 times 4.2, which is 8.4t plus 3. And that gives us our expression for speed. So this here is basically the expression for speed. Now you can see that the speed isn't constant because as the time goes on, as the value for time changes, the speed is also going to change. As the value for time increases, the speed increases. And for that reason, we know there must be an acceleration. But the question is, how do we get an acceleration? Well, remember, this is the speed here, but the acceleration, and this is again from the last lesson, the acceleration is dv by dt, or to put it another way, it's d2s by dt squared. So because we have this, we have to differentiate this again. The acceleration is basically differentiating this expression above for a second time. And if we do that, and we differentiate this again with respect to t, then we get 8.4. So in this case, the acceleration is 8.4 meters per second squared. And that's us done. That's how you do those types of questions.